Okay, now this is just to show the output from the two cells today. It's 162 watts, and I'm checking kilowatt hours per day, so I know I can look at my bill and see what I should be seeing on the next bill, how much I'm putting back in. And it's been running for a couple of hours, and we're almost half a kilowatt for today. So I figure about 1.5 kilowatts per day at 200 watts, like 6 hours. So and this is the worst because of the angle of the sun on the panel. Here you can see I got a 600 watt inverter. This is a grid tie inverter. All the inputs come into your positive and negative here. These things have to be plugged in first so they can read the sine wave of your AC, and the power goes right back into the outlet. And you can see we've got a kilowatt meter on here. I can check how many amps it's putting out. I can check out how many watts it's putting out, and it goes back through that as 110. So anyway, the inverter matches your sine wave of your power grid, whether you've got your house running from the power company or whether you've got a generator running. The grid tie inverter will match that sine wave, and whatever comes into that inverter will go out as power into your grid. If you don't have anything else in your house turned on, then your meter should turn backwards if that power inverter is putting out. So anyway, I just run the wires into the inverter. I left enough room there, so if I want to add more inverters and gauges, whatever I want, but this 1 kilowatt meter plugged in on each one of these inverters will do the trick for you. You won't have to use any kind of voltage gauge, because you can see everything you need to see there except for the input voltage. So this one is a 14 to 28 volt. Let's see if I can get it. 14 to 28 volt input, and you'll see that the lights on the back flash in series, 1, 2, 3, and if everything's good, then they'll be flashing like that. If there's something wrong, then there'll be the red light next to that fault that'll come on. It's pretty simple. The difference between this inverter and other inverters is that this inverter goes right into the grid. That's why it's called a grid tie inverter, and it matches the sine wave that's being put out by your power, and puts it into the line. So I'm going to try to show you where the sun's at here. Okay, the sun is over there, that big dark spot in the middle, nice, and the panels are right here. So the angle of the sun to those panels is about like my hand is, less than 45 degrees. So what I need to do is lift those panels up on one side and lay them like that on the roof, and that'll be the next project that we're going to do. I'm going to make some wedge shaped pieces, oops, to put underneath each one of those panels and turn the panel up like that, and then we'll be able to catch a lot more of that sun, and our watts should go up. So that's what we got for now. Alright, so this is the setup for cutting the wedges for the solar panels. So when they're laying on the roof, I can put them at that angle. What I did is I took 4 4x8 sheets of just plain styrofoam insulation. I glued 4 sheets together with caulk, and then I set up my wire. You'll see this set up here. I've got one screw to wrap the wire around and the other screw to lock it down, and that allows me to tighten that up whenever I start heating the wire. And the wire, as you can see, runs from over there on my guide to down here on the screws attached to the concrete. And the same thing, I wrap around the first screw and tighten it on the second one. Then I've got a connector there that's just crimped between the 2 wires. It just crimps the 2 wires together, although you could bend the wire like I did on the other side and just plug it in. And I got the table supporting the wire that goes across from my other support over there to suspend that wire, so that what I have is a cutter that is set from one corner to the other corner, and I've screwed this board down to the concrete so it gives me a guide, a straight edge to follow. It's 12 foot long, but it doesn't really matter. It just needs to be longer than your plywood or styrofoam, so that you can start it on your wire and push past and keep it on that guide. That gives you a nice straight wedge. So what I have now is 2 wedges. Let's see if I can. So I have 2 wedge shapes now, and I can take those 2 wedge shapes, slide them underneath my 4x8 solar panels, and get the winter and summer sun. Well, more of it. So we'll see what happens. And these are the wedges installed. It's kind of hard to get a perspective on them there. You can see how the ribs on the roof run, and those solid styrofoam wedges support the glass from underneath, since it's smooth on the back, and that gives me a little bit of angle for the wintertime sun. Now come summer, I'll swap those wedges around the other side and have them facing towards the sun in the summer. I don't know if you can see it there, but I've got hinges on this side and that side, and the hinges on that side are not connected right now. There's a strap, 2 straps that go down to the roof and hold that side down, but there's no wind load underneath it, so the wind's just going to blow over them. Come summer, spring I'll lay them down flat, and then summer I'll switch the wedge around to the other side, disconnect the hinges on this side, and connect the hinges on that side, which I'll have already done in the spring, and spin that wedge around, and then I'll have the panel facing the other direction for summer. So anyway, just an idea. Okay, we're back checking watts at about 12:30. Reading about 175 watts right now. That was up over 200 this morning when the sun wasn't even at a very good angle. That's about 177 watts. You can see the sun is behind this chemtrail cloud, and these are all chemtrails from today. I've been watching these airplanes laying down chemtrails. I just made another video of it. But those trails knocked off at least, that cloud right there, knocked off at least 30 watts on the panel. You can see the panels are angled a little bit better towards the sun. The angle of the sun right now to the panel is about this, so we're getting better than what we had, but we still need more angle on the panel. And you can see that the shadow being cast from that one is touching the other boards on the other panel, but it's not blocking any sunlight on that panel, so that part's all good. If I was going to raise that panel up any higher, I'd have to move those panels apart so that I wasn't shading the other panel. Something else I want to do here is, real quick, just spray water up on them panels and cool them off a little bit, and then go back and check the outputs. So I'm going to spray them off, and you'll see steam coming off of them too, so they definitely get hot. So I'm going to cool it and then go check my readings again, which I've already done once, and it made about a 20 watt difference. So we'll see if it gets it up over 200 by doing this, because that sun's still behind that same cloud. So this will show you what kind of difference it makes when your solar panels are cool versus hot. They won't be completely cool, but they'll be cooled off quite a bit from what they were. Okay. Now we'll go in here and have a look at the output, see if it changed. So it's gone down a little bit. It could be the water on the surface of the panels doing that too. But as it dries, that should start to come up. Yeah. I don't know, maybe there's a bigger cloud out there than what there was before. It looks like it's pretty cloudy now. Well, there's a brand new chemtrail getting laid down. But yeah, it's pretty cloudy. It's a pretty thick cloud. So, looks like our outputs are going to be messed up again today because of these chemtrails. That's not a cloud, you know. Look around, you'll see a cloud, but that ain't one of them. That's a chemtrail cloud, just like all the rest. The pictures out here earlier today, maybe an hour ago, none of this was here. None of it. And if you look closely, you'll see how those lines have sort of melded together. And they're still laying new ones. So, that's the crap we're breathing. It's the crap that's landing on our plants, stuff we're eating. Hope it's good for us. Probably not. So it doesn't look like we're going to get a good reading out of our panels today. But, you know, a couple hundred watts out of 600 watt panels that are not optimized. They're not facing right at the sun. And they're not getting clear sunlight. So, you know, I can't complain. I got, I think I've spent $150 on the inverter. I got about $300 in the, well, probably $400 in the solar panels with tabbing and solar cells and all that. Maybe $450 now that I had to buy $60 worth of insulation to make those wedges so that I could change the angle of the panels. But altogether, I think I've got about $500 wrapped up in the solar panels. I got the glass for free, and I just taped the backside